My name is Maxwell Bland. I'm a graduate student and researcher here at UCSD. I study embedded devices and reverse engineering of firmware. Today we're going to be looking at reverse engineering the measurement cartridge for a typical hospital blood gas machine, such that the measurement cartridge won't expire and you can get infinite health cartridges. So these cartridges are typically single use with a 28-day countdown timer. That means that once you put it into the machine, you can't take it out without invalidating the cartridge. Additionally, if 28 days go by, the cartridge will be considered invalid as well. So this is a cartridge which we previously used. When we go ahead and insert this into the machine and close the door, we will see that the device is going to tell us that it needs replacing. So the measurement cartridge needs replacing, and it's considered invalid. The first step to getting infinite health cartridges is actually to understand how the cartridge expiration data mechanism is happening. So on the top of the cartridge here, we can see that there are around 30 contacts, as well as an EEPROM memory chip. The EEPROM memory chip, using a multimeter, can be seen to have 5 pins corresponding to ground, clock, data, voltage, and write protect. Now, write protect is grounded, but the other 4 pins are actually set up to connect to the contacts immediately to the left of the EEPROM. Awesome. So now that we know this, we can go ahead and try to read the data out of it. We can now rig up a microcontroller with the 4 pins that correspond to the contacts here to read out the data using commands from the Atmel datasheet. So if we go ahead and just put this on here and run a bit of C++ code that we have written on the computer, we should be able to get a hex dump of the EEPROM. So go ahead and upload this, and contents verified, page match. So now we've got a hex dump of the contents of the EEPROM, and we'll be able to reverse engineer it by cross-validating with a fresher cartridge and trying to look at what's sort of in the program. So the real magic happens when we start to look at the hex dump from the program. What we see here is a bit of copyright information, serial number, some dates, and some other metadata about the cartridge. The next natural question is, well, can't we just read out a brand new fresh cartridge, write it into the EEPROM, and get a valid cartridge out of it? The answer, sadly, unfortunately, is no. Because the serial number gets stored inside the machine, and it requires some sort of checksum. Guess we just have to give up. Or maybe not. The blood gas machine pictured here, it actually has a security vulnerability in the distributed component object model remote procedure call interface running on port 135. That means that we can get remote shell access to the machine in question and overwrite or look at the logs. So now we can go ahead and return to our setup that we had earlier. This time, instead of reading the EEPROM, we're going to write to it. We'll write to it the hex dump matching a fresh cartridge with a valid checksum, but a different serial number than before. So if we go ahead and plug this in, should be able to verify, run, and now we've written a fresh cartridge. So if we go and take this and put it back into the machine, our hope is that it's going to just work right out the box. So let's go back to our interface, back here. Remember, it says cartridge needs replacing. And we see here that it is working. So with that, boom, we've created a infinite health cartridges hack with a little bit of knowledge of an EEPROM, a little bit of knowledge of microcontrollers, and now we have, ostensibly, we can repeat this process as many times as we want. Next week, tune in. We'll be talking about how to get infinite money. All right, thank you so much, and I'll see you later.